So on this video, I'm going to prove you that the plus of 1 is equals to 1 over s. Also for plus of t is equals to 1 over s squared, and raised to at is equals to 1 over s minus a using Laplace transformation. So first, Laplace transformation has its kernel transformation, which is the term e raised to negative st. So to prove that the plus of 1 is equals to 1 over s, we evaluate this like this. Integration with limits of 0 to positive infinity. Integration of e raised to negative st times 1 dt. Since it is 1, we can also say that it is equals to this term. So integration of e raised to negative st is equals to negative 1 over s times e raised to negative st with limits 0 to positive infinity. Then we're going to substitute the limits on the function. So first we're going to use the higher limits before the lower limits. As you can see here, this term, as it approaches infinity, it will be equal to 0. So you can evaluate this now with this term. Also, on this term, any number raised to 0 is equals to 1. So we can also evaluate this as this. And negative 1 over s times 1 is also equal to negative 1 over s. But we still have negative sign on the outside, so we have to distribute it inside, and we can come up with an answer of 1 over s. So we prove that the plus of 1 is equals to 1 over s. Okay. Next. The plus of t is equals to 1 over s squared. So to evaluate this, we also need to use the kernel of transformation and evaluate the equation like this. So on this Laplace transformation, we can see that we have an exponential and another function. So we have to use an IVP. IVP stands for integration by parts. So we're going to use t as a u because e raised to negative st is exponential. We can get these terms. So we're going to use IVP with the formula UB minus integration of V du. And then we're going to evaluate this equation. So RU is T multiply by the V, which is negative 1 over S times E raised to negative ST. Evaluate with 0 to positive infinity, and the integration of v du, where RB is equals to 1 over S E raised to negative ST. Then our du, which is dt. So in this case, this term, as we see, as it approaches again positive infinity, will be equal to 0. Then we can evaluate this equation again with this term 1 over s over 1 over s to negative st dt. As we can see, this term here, we can call this part as coefficient. Coefficient is somehow we can take it outside the integration so that our integration makes it easier. Then we can come up with this term. So we're going to integrate again e raised to negative st, which is equals to 1 over s, and we can come up with an answer of 1 over s squared. So now we prove that Laplace of t is equals to 1 over s squared. On this part, I'm going to prove now that the Laplace of e raised to at is equals to 1 over s minus a. So this is how it goes. Again, we're going to evaluate this integration of 0 with limits to 0 to positive infinity. Then substitute the functions. As we can see, these two terms have the same base. So we can evaluate this as this. A minus s times t dt. And we can continue now on our process. So the integration of this term will be equal to 1 over a minus s times e raised to negative a minus s times t with limits 0 to positive infinity. Again, we're going to evaluate it with the limits 0 to positive infinity and come up with this equation. A minus s times positive infinity minus the lower limit 1 over a minus s e raised to a minus s times 0. As we can see, this term again will be equal to 1, so we can evaluate this as this. This one will be evaluate as 0 again. So we can come up with this form. So negative 1 over a minus s times 1 also equal to negative 1 over a minus s. To cancel out the negative sign, we can also say that our answer is equals to 1 over s minus a. So now we prove also that the Laplace of e raised to at is equals to 1 over s minus a.